Okay, so now that we've learned about chemical reactions, we're going to talk about balancing chemical reactions and what that means. Now, balancing doesn't necessarily mean that you're going to balance like all of these talented people and horses, but it is similar. You do want to find a kind of a middle ground where things are equal and can balance. That's exactly what we're going to do with our chemical equations. And I'm going to tell you why we have to balance them. Because of this guy, Antoine Lavoisier, a French scientist from way back in the day, very, very smart guy, came up with this law for science. And the law is called conservation of matter. And what the law says is that matter cannot be created nor destroyed. Okay, so we do not have the power to have atoms appear out of nowhere. We can't create them. And we can't have atoms just disappear. We can't destroy them. All the atoms that exist have existed since the beginning of time. And we as humans do not have the power to create or destroy any of those atoms. So they just get changed and rearranged. That's all we can do with them. No creating, no destroying. So because of that, we have to make sure that we're keeping track of how many we have. When we have a chemical reaction and we're creating a new substance, whatever atoms we start with, we better still have those atoms at the end. We better not have any extras, and we better not lose any because we can't create or destroy any matter. Okay? So, in order to make sure that we don't get any extras or lose any, we actually have to be able to count atoms, okay? The rules for counting atoms, subscripts, which are those little numbers down to the right of our elements, apply only to the element that they're after, okay? Coefficients apply to the entire chemical that they're attached to, and I'll show you what I mean by that. Okay, so we're going to look at a couple of examples here. This small number here, this is a subscript. These big numbers out front, those are called coefficients. So the first rule was that subscripts only apply to the element that they are after. We've learned this before. We learned this earlier in the year. So this 2 means that we have 2 H's. If there's no subscript, that means that there's 1 of that element. So in this water compound, or molecule actually, we have 2 hydrogens and 1 oxygen total. 3 atoms total, 2 of them are hydrogens, 1 is oxygen. Okay? If you put a 2 out front, that means we have 2 whole water molecules. It means we have 2 copies of that. And again, this is review from earlier in the year. So if we have 2 water molecules, you actually have to distribute this 2. You have to multiply it. 2 times 2 will give us 4 H's. And 2 times 1 will give us 2 O's. Okay. Here, we have a 4 out front. 4 times 1, we can't see the 1, but it's there, is 4. So we have 4 iron, Fe's. And 4 times 3 is 12, so we're going to have 12 chlorine atoms in this equation piece. Okay? Over here, 2 times 1 will give us 2 carbons, and 2 times 4 will give us 8 hydrogens. All right, now it can get a little tricky when you add parentheses in here, okay? Again, a subscript applies to everything that it comes directly after. So this 3 applies only to that oxygen, but this 2 applies to everything in this parenthesis. So it does not apply to the calcium, just the NO3. So we have to actually distribute this 2 as well. So for calcium, we just have 1 of them. And then taking this 2 and distribute it inside the parentheses, 2 times 1 is 2, so you'll have 2 N's. And 2 times 3 is 6, so you'll have 6 O's. And the hardest one would be something that has a coefficient, subscript, and parentheses. You're going to have to distribute this 2 and this 2. Okay? So 2 times 1 will give us 2 calciums. Okay, then you have 2 times 1 is 2 for the nitrogen, but you also have to multiply it by 2 again, so you end up with 4 nitrogens. Okay, for your oxygens, you take the 2 times 3, which is 6, and then you have to multiply that by 2 again, which is 12. So you have 12 oxygens. Counting atoms is the most important piece to being able to balance. You have to be able to know how many atoms you're starting with to make sure that you're ending with the same number, so you know you're not breaking that law that Mr. Antoine came up with. So we're going to look at an example here. Okay? Water is made from which two elements? There's two different elements in water. If you back up, here they are. So we have hydrogens in water and oxygens in water. Okay? So the two elements are hydrogen and oxygen. Right? Hydrogen as a molecule is H2. Oxygen, and that's what it looks like, two hydrogen atoms. Oxygen is O2, which is two oxygen atoms bonded together. Okay? So here are reactants, and we're going to combine them to produce water, H2O, which has two hydrogens. Remember, hydrogen is yellow, and one oxygen. Okay? Again, hydrogen and oxygen are your reactants. Water is your product. Okay? So let's look at this then. You have your hydrogen and your oxygen combined to create water. Now, everything that we start with, everything on the left of the arrow, all of those atoms have to be accounted for on the right side of the arrow. So you look, you go, okay, we have two hydrogens here. That's good. If you look on the right side of the arrow, you have 1, 2 hydrogens. So good. We didn't lose any hydrogens. We didn't gain any hydrogens. That's good. The hydrogens are balanced. But if you look at our oxygens, over on the left of the arrow, we have 2 oxygens. To the right, we only have 1. So as this equation is written right now, it looks as though we've destroyed an oxygen atom, which is, like we saw earlier, it's against the law, the science law of conservation of matter. So this is not a balanced equation, nor could it actually exist because we're not allowed to destroy any matter. So what can we do? Well, the only thing that we have available to us, we can't change this chemical equation, but what we can do is make copies of any of the pieces that are already there. So since we have 2 oxygens here, we need another oxygen over here. So what we better do is put a 2 out front, which means we want 2 copies of that water molecule. Okay, 2 of this whole thing. What that looks like is you're just going to add another copy. So you go, okay, great. We have 2 oxygens on this side. Now look, we have 2 oxygens on this side as well. But it created another little problem for us. If you look at your hydrogens, now we have 4 hydrogens on this side and only 2 on this side. So is there a way that we could get 4 hydrogens on this side? Well, yeah. If you make another copy, say you want 2 copies of that hydrogen instead of just 1 copy, now we have 4 hydrogens on this side, 4 hydrogens on this side, 2 oxygens on this side, and 2 oxygens on this side. Since all of the atoms we started with are all accounted for in the products, this is now considered a balanced chemical equation. Okay? We didn't create any atoms, we didn't destroy any atoms. All we did was take these atoms and rearrange them and bond them differently to create a new substance. Okay? So the balanced chemical equation then would be what we have written up here, including the 2's that we added in. Okay? So when you are balancing chemical equations, it's really important that you know the only thing you can do is add coefficients. Okay? Meaning we can only make copies of what's already there. You can't just say, oh, let's just make this H2O2, because H2O2 is not water. You can't just make it into a new chemical. You can only make copies of what's already there. So you can only add these big numbers out front when you're balancing. Okay? Do not add any subscripts. Resist the urge. So let's look at this really quickly. Here's another fairly standard chemical equation. You have chloride combined with sodium bromide to create sodium chloride and bromine. All right, so here, if you look, over on the left side of the arrow, we have 2 chlorines. And if you look on the right side, we have only 1 chlorine. So where do we need more chlorines? We need them more on this side, right? So what we can do is we can make another copy of this NaCl. So okay, now we have 2 copies. So that's good. Now you can see there's 2 chlorines here and 2 chlorines here, 1, 2. So the chlorines are balanced. You go, okay, what about the next element, Na? We have 1 Na over here and 2 over here. So that's not good. Where do we need more? We need more NAs over here. So what we do, we make another copy of that substance that has an Na in it. Say, okay, Na, now we have 2 NAs and 2 NAs. And then you look at the last chemical, Br. Over on this side, we have 1, 2 Brs, And over here, we have 2 Brs. So you go, okay, let's just double check this really quick. 2 Cls, 2 Cls, 2 NAs, 2 NAs, 2 Brs, 2 Brs. As long as they are all equal, you know that it's balanced. So then you have to write this balanced equation, okay? You write the balanced equation, you just want to say how many copies of each do you have? So how many times did we write Cl2? We wrote it once. How many times do we have NaBr written? It's written twice. We have 2 copies of it. Here you have 2 copies of NaCl, so you put a 2 in front of that. And you have 1 copy of Br2, so you put a 1 in front of that. Okay? Now, to save ourselves time, just like we don't write ones in our subscripts, we also don't have to write these ones when we're balancing. So truly, the best way to write this balanced equation would be this at the bottom. Whoops. So it's the same as this, it's just that I took out the ones now. You do have to write the 2's in there. All right. Now, there is a shorter way of balancing equations. It's called wrapping it, where you're comparing your reactants, atoms, and products. And I can show you this shortcut if you'd like when you're done with these notes, or you can do it by drawing out your copies like we just did. All right. So if you want me to show you a quicker way to do this, you let me know. Otherwise, you can work on your balancing practice sheet.